Module 6, Web Performance and Cloud. Lesson 6.1, Content Delivery Networks.
Why do some websites load instantly, but others slowly? The answer often comes down to distance, and distance takes time to travel. CDNs exist to solve that.
The distance problem.
When a website is hosted on one server in one location, every user in the world must connect to that same server. The farther the data has to travel, the longer it takes. This delay is called latency. Even at the speed of light, physical distance still matters. More distance means more network hops. More hops means more delay.
What is a CDN?
A CDN, or Content Delivery Network, is a global network of servers that store copies of website content in different locations around the world. By placing content closer to users, it reduces the distance data has to travel. This helps websites load faster for people in different regions.
How CDN edge servers work.
These distributed servers are called edge servers. They sit at the edge of the internet, closer to users than the website's main server. When a user visits a website, the CDN automatically routes the request to the nearest edge server. If the content is already stored there, it can be delivered immediately.
Caching explained.
CDNs improve speed using a technique called caching. Caching means storing copies of frequently requested content, such as images, videos, and scripts. When a user first requests this content, the CDN stores a copy on the edge server. When another user requests the same content, the request no longer needs to reach the main server. The edge server can deliver the cached copy immediately. This makes the response much faster.
Why CDNs are necessary.
CDNs significantly improve website speed. By delivering content from servers closer to users, pages load much faster. Faster websites create a better user experience and often rank higher in search engines. Without a CDN, every user request must reach the main server. As traffic grows, this server can quickly become overloaded. With a CDN, most requests are handled by edge servers. This reduces the load on the main server. CDNs also improve reliability. If one edge server becomes unavailable, requests can be routed to another nearby server. This helps keep websites online even when individual servers fail.
CDNs and security.
Modern CDNs help enforce HTTPS encryption. HTTPS protects the communication between users and websites. It ensures that data traveling across the internet cannot be easily intercepted or modified. CDNs also help protect websites from DDoS attacks. In a DDoS attack, a server is flooded with massive amounts of fake traffic. This can overwhelm the server and make the website unavailable. Because CDNs distribute traffic across many servers, they can absorb and filter much of this malicious traffic.
How CDNs actually route you.
We learned that the CDN sends you to the nearest edge server. But how does it know which one is nearest? Most modern CDNs use a routing technique called Anycast. With Anycast, many servers around the world share the same IP address. When a user makes a request, the internet automatically routes it to the nearest available server. When you type a website's address, your request is routed through the internet's backbone. Internet routers automatically send your request to the closest or most efficient server advertising that IP. That decision is made using BGP, the Border Gateway Protocol. The user doesn't choose the server. The network chooses the best route in real time. If one edge server goes offline, routing automatically shifts to another.
Major CDN providers.
Cloudflare. Cloudflare operates one of the largest global CDN networks. It improves performance and protects millions of websites. Akamai Technologies. Akamai was one of the earliest CDN providers. Today, it delivers a significant share of global internet traffic. Amazon CloudFront. Amazon CloudFront is part of AWS. It integrates CDN capabilities directly into Amazon's cloud infrastructure, making it easy to distribute content globally. CDNs improve performance by reducing how far data has to travel, but they don't eliminate the need to fetch content from the original server. That's where caching becomes important. When content is stored on edge servers, it can be reused instead of requested again. Reduces repeated trips to the main server and makes delivery much faster. CDNs rely heavily on caching to achieve this. In the next lesson, we'll look at caching in detail and how it helps systems respond more efficiently.